Hello. Hello. Thank you for joining us. Hello, this is Liang from Nile Quantum Insights. Today we are going to learn how to use Python Polars library to clean and transform data. And the data that we are going to work with comes from CMS website, or CMS is the Centers for Medicare and Medicaid Services. So we are going to look at US hospitals, general data that is publicly reported. And one thing you can learn from this data is you can look at your state or your city and see which of your hospitals or how your hospitals do in different categories. One of the main method or criteria or program that is used by CMS to rate hospitals is the hospital overall quality or quality overall rating, which is a star rating program. So maybe we are going to give it a few minutes. I don't know if there are people who are going to join, but maybe we give it 2 more minutes and then we can showcase what we are doing. The most important thing here is to show data scientists and analysts, especially those coming from R to Python, to learn how to perform data wrangling with the Polars package. I have done some setup to save time, but within the IDE that I'm using is the new IDE by Posset, or the former R Studio company, which is called the Positron. Positron. This is a great IDE, and you can use it whether you are using R or Python or Julia. I'm using Jupyter Notebook. I could have used I like Quadro, but this is relatively new. It's still a public beta version. So I just like to use Jupyter Notebook for this purpose. So let me go ahead and start or we start our program. So we thank you, those who have attended. You can comment and we'll be able to see your comments here and we will reply to them as we find time. For those interested in data science, you can request, you can join to watch me do what I'm doing live with me. I'm okay with that. If you are interested, I can inbox you the link. Okay, so I've already mentioned that we are going to analyze the USA hospital data, because sometimes you want to find a good hospital in your area. And here, this data is going to show us how to find out that information. There are two objectives here. One, to learn how to perform data wrangling or data cleaning and transformation using the Polis package. And two, also to glean some information about US hospitals so that you can make informed decision about your family, and you can go and do more research on this data so that you learn more about the hospitals in your area. So what I'm doing here is the first step is to load the libraries. We call them libraries or packages. And a library is just a collection of functions that are used for specific purposes or purpose. So the first library we are loading is called Polis. This is one of the, or it should be the fastest Python library for data wrangling. The most prominent and well-known data wrangling package in Python is Pandas. But I recently decided to transition to Polis because of its similarities with dplyr from in R. And then the second thing I'm loading there is Polis.selectors. Selectors, these are helpers that help you work with data. It could be working with columns or working with rows. I'm also loading plot9, and plot9, I'm saying from plot9 import star, that is, I'm importing all the functions from plot9, which is insane because there are a lot of functions there. I don't know if we will have time today to go to the plotting part, but plot9 is the Python version of ggplot2. And then from Mizani.labels, this is a package that is used to format plot labels in plot9. I don't know if I'm going to get to the plotting part, but we can reserve it for next time if we run out of time. And then I'm also importing sys to print out my system version. And the Python version I'm using here is 3.12.4. And the Polis version I'm using is 1.2.1, which is a development version. And then after that, I'm going to import the data. So this is the link. I have already downloaded the data, but I can quickly show you where the data is coming from. So let me click here. You can go online and type in hospital general information, and it's data.cms.gov. And this is the data that I'm using. It's arranged by facility ID, and then the facility name, address, city or town, state, zip code. There are a lot of columns, about 39 columns here. You can learn more about the data here. And this data is made up of 5,398 rows. It was last modified on July 8th and released on July 31st. So it's up-to-date data. Some of this data I work with regularly at work. And so I've talked about overall hospital rating. This is one of the information that we are going to investigate in this report. So what I did, I just click download. You can click download this and save it somewhere on your desktop. You can learn more about the data by clicking the dictionary and you read this document, but we are not going to do that. I have already downloaded the data, so we are going to go straight into the data. So what I have done I have set the data here. So this is the data. I right click it, copy the relative path. You don't want to use the absolute path, like the whole path, because when you do that, it's going to copy your user information. And you don't want to share that because each system or every user has different system. And it is not advisable to use absolute URL or path. So just copy the relative path, which is just taking me into the folder, data folder, and then into my data. And then next we are going to, so we will name it, let's call it hos for hospital underscore raw, and then we are going to use we have imported Polus as PL, and then from Polus, we are going to read, this is a CSV file, so we are going to call this CSV. And then just put in the URL. We could have just copied that URL and put it in there, but just make it short. You can just keep it clean by just saving the URL and then typing only URL in there. And then here, there are other options that we can include. We can include like null values. If there are null values and you want to set them, let's say we want to set them to NAs, this is not applicable here. There's another one that we can use, let's say strict. So let me try this. Okay, let me run this. And then when we do that, we are getting an error and it is telling us specifying correct data type with the D types argument, setting ignore errors to true or adding 1623 to the null values list. So this is giving me some ways or has some ways to correct, to fix the data error that is originating from the data. So what I'm going to do is I'm going to ignore errors and I will set that to true. Because this is one way to do that. So I'm going to say ignore errors and then I'm going to set it to true. And then let me pull this one to the left side, make it wider. And then what I will do here, I'm just going to inspect the output. That is, I will print it out. Make sure that it is coming in as expected. As underscore row. And then in Jupyter Notebook, I'm just going to press Shift key and Shift return key on my keyboard. And this is the data. So this data is 5,000. So this is another way you can show 1,000 in Python underscore 5,398 rows or observations and 39 columns or variables. It's not all these columns that we are interested in. Some of them are important, others are not important. Like for example, I'm not going to need the ID column. And then when you scroll all across, we may need the state, we may not need the physical address, we may need the city, and then this patient experience group footnote. So anything with footnote is not important. We are going to remove those. And then T is time and efficient, timely and effectively, which is one of the measures. There are 5 measures in hospital rating or the system that the CMS use for hospital rating. So here we are going to look at these measures. One is going to be mortality, readmission. I talked about timely and effective domain. We'll also look at patient experience of care, which are the surveys that you do when you are being released from the hospital. And then the safety domain, yeah, those 5. Okay, so this is how you read in the data. It's a CSV. If it was Excel, we could have used the read underscore Excel, but it's a CSV file. So that's how you read it into Polus. And then now the next thing is we want to see how to pull out the columns, because you see there are a lot of columns here, 39 of them, and Python does not, or Polus does not display all of them. So kind of like condenses that so that it fits on your screen. So we want to understand the columns. What we can do is call our data frame and then dot columns, and then we can print this out. And this is going to show us a list of all columns. And this is also has been truncated because it's too long. So some of it has been cut out and shown using the dot triple, like 3 dots. So these are all the columns here. It's important to understand your data before you import it into Python, into Jupyter Notebook. You need to be familiar with your data so that you know what are the important columns, rows, and so on. Looking at these, there are columns that we are going to remove. For example, I have already mentioned any column with a footnote in it, we are going to remove that. And we will learn how to do this in the best way later on when we talk about selecting or working with columns. So each column here is a measure, and each measure has several columns. For example, the safety group measure count, and then the count of facility safety measures, and then count of safety measures better than national average, those that are no difference from national average, and then those that are worse than national average. Usually, as a hospital, you want to be either no different from national average or better. You don't want to be below. But sometimes situations dictate where you fall on that line. So this is how you pull out the columns. And next, we are going to see or identify, check our data if it has missing values. The way we do it, here I'm going to use a method chaining. So you open parentheses like this, type in your data frame, and I'm going to use the select method. Select method is used to work with or select columns. With columns is used to modify existing columns or add new columns. But let's look at select method first. So when I initially, when I imported the libraries, I imported polus.selectors as CS. So I'm going to say CS and then all. There are a lot of options here. You can check for integers or strings and so on. But here I'm going to say all columns. And I'm going to see one way to check missing values is to call the null count method on that. It is calling it on all columns. And then when you do that, now it's showing, so facility ID, there are no missing values there. But when you scroll to the right, you'll see, for example, meets criteria for promoting interoperability of EHRS. It's missing 1,500. And then the next one, which is if the hospital is birth friendly, like hospitals that have certification in like breastfeeding. So that's another recognition that CMS gives hospitals. So it's missing like 3173. And then hospital overall rating footnote is missing some values, but that's not important. That's we have already talked about that. And then mortality group footnote, that's not important. So we see here missing values actually are in the column that are not that important. So that's a good news. Usually, when you find a data with missing values, you would want to understand why those are showing as missing values, because missing values could be attributed to human errors like data entry errors. It could be something wrong with the data, or it could be intentional. So you always want to work with the domain experts. This is a healthcare data, so you would want to work with somebody from CMS or somebody who has a better understanding of CMS reports data in general. Another way we can check missing values, I'm going to do the chaining again, is instead of calling the null count, we can do this and say select CS all columns, and then I'm going to call dot is null to see if there are null. But when you just call this, it's just going to give you columns of true, false. So let's run it. It's just going to show all true, false. But in programming here in Python and Polars, true is always equivalent to 1, and then false is equivalent to 0. So what we can do is chain on sum to this to sum all this. And then we ended up with the same thing that we got above. So there are two ways that you can check for missing values in Polars. Next, we are going to work with columns, select columns. There are different ways we can select columns. The goal is usually to use the most optimal or method that will save you typing. You don't have to type a lot, and also you want robust, like optimize the process. So let's add a code chunk here. And then, so here I'm going to do a chaining again. The data, then we are going to select, we are going to say, so let's go back to our columns. We pulled them out here. We see most columns here have or contain the word measures or major. And also they contain, or they start with count. Some of them end with the footnote, like here. So this is going to give us some hints on how to simplify this process. I have already mentioned that we don't need any column with a footnote in it. And since there are variations in this is saying footnote lower cases. This is saying footnote capitalized. So best thing is maybe I'm just going to say ends with note. And that is one way I can pull out those columns. So let's come down and say here, okay, select, and then we are going to call the selectors. And then we say all. So we are looking at all the columns. Then I'm going to say ends with let me try this. It ends with, and then we will say note. Let me see. Okay. So that's not what I want to do. Let me, okay, so let me do this. So with columns, We want columns that ends with this. Well, okay, so it says expression object has no attribute ends with. Okay. Okay, let me check something here. Okay, so I'll see what I'm doing wrong. Okay, so what I was doing wrong was that I'm calling CS and then all, which is taking me to just transform the raw values instead of the columns. But this is what you do. So it's a CS, select CS dot ends with. We only wanted all these columns that end with the footnote. But our goal is not to keep them. Our goal is to remove them. So what we can do is, so I'm going to copy this one. Instead of removing that, I'm going to copy it. And I will not remove it there. I'll come down here, add another code chunk, and say, okay, now we have seen those and we don't want them. What I can do, I can call all the columns, and then I'm just going to subtract by saying minus. I'm just saying, give me all the columns, excluding these columns that end with footnote. And now this is what we get. We have removed all the columns that have footnote in them. But again, we don't want the ID column. We don't want the address. We don't want, so there are a lot of columns that we can still remove. And so another thing we will have to do there is, let's say, I'm going to put this in parentheses, and I'm going to say, if it ends with note, or if column is a facility ID. So let me copy this one. And then now let's remove that. Now we have removed the facility ID. And what I did was just saying, okay, give me all the columns, but exclude. So I wrap this in a parenthesis so that I say if it ends with note or it is a facility ID. We can do that with the address and this, but this can become tedious. So how you decide whether to select the columns to keep or select the columns to remove. If you have more columns to remove, then it is better for you to select columns to keep. If you have more columns to keep, then it is better to remove the columns that you don't want. So that's how you decide what to do or how to approach this problem. And then we could have done like this. So we could have said our data frame that select, and then we come here. I want to pull out all the columns. Dot columns. And then that's it. And there are a lot of them. Yeah, some of them have been included. So you want to capture all that. So let's say we just copy this. One way we can do is say calls outside and set it to this list like this. Copy this from the bottom and put them there. Remove these. This is not capturing all the columns, but I'm just showing you another way you can select this. You see here there are a lot of these, and then let's say we bring in the codes here. Let's see if this is going to work. Yep, and that works. So this is another way you can do it, but this is a lot, like you guys see, this is too much information. So using with the selectors is better. And you can narrow down all the columns by just using these words. So another thing that I have seen here that we can do is when we go back to the columns, we have seen that all the columns that we are interested in, instead of just looking at the word measure, so we have removed those, but now we want the columns of interest. So we could just say, instead of you looking at the measure, we can say, okay, if it contains count, then give it to us. And then we are going to couple that with the facility name, state, maybe hospital type, hospital ownership, and emergency services. I don't know if those are important. I may not be interested in these other two columns here, but I want hospital rating because that's one of the things I'm interested in. So let's come down and select these columns again. So what I will do first, I will transform the columns so that they are well formatted. And that is, I'm going to change all the columns to lower cases. I will replace spaces between them with underscores. I will replace this forward slash with underscore just for demonstration purposes. And then after that, we will select the columns that we are interested in. So here, let's transform columns. This data, we are going to rename it hospital general information. We want to save it, and then we take our raw data. And then, so I'm going to use the rename function. I will use the lambda function. So lambda is like anonymous way of, or writing anonymous functions. So I'm going to say column for columns for colon call. We are going to lowercase this one. Let's run it and see. So the other thing we need to do is inspect the output to make sure that it ran as expected. Sorry, I need to tell Python this is a comment. So print host general information. Let's run it. Control Shift. And then we have converted all the columns to lower cases. And then now that's not what the only thing we want. We want this to remove these spaces. So what I can do, I'll chain on replace method. And I will say, okay, look inside. If you see any space, replace that space with underscore. And now these spaces have been replaced with underscores, but the forward slash has not yet been replaced. So we chain on another replace method. We cannot do it at once. And then we are going to say, if you see a forward slash, replace it with underscore. And then now we have cleaned our column names. Here. And then we can now work with these columns. So another thing we are going to do here, we will take that data. We take hospital general information. I'm going to change it on. So now I'm going to select the columns of interest. So we will say select. And the first thing we are going to do, we will select the hospital name. So let's say hospital is facility name, actually, facility name. And then let's use and say contains count. Let's try that and see what will come out. Yeah, so we got those. It brought the county, but we are not interested in that. We just need these columns that have counts in them. Okay, but that is missing the star rating. So we are going to say, let's go back and see. So hospital overall star rating. I will copy this one. We have transformed this one so there are no spaces. So now we have the hospital star rating. We don't want this county or parish. So we are going to remove it. So we'll say minus PL called Dutch county underscore parish. See if that is going to do it. So that's it's not doing it. Let's see. Okay, so that's not going to work. Okay, let's keep these columns. So we are going to keep these columns, and then let me try this one. Dot exclude. Okay, so now we got rid of that. So the way we got rid of that parish, county or parish, is to chain on the exclude method onto CS that contains, and then that excluded that column from our data frame. And then now we are going to call this hospital. Maybe let me just call it hospital. And then we will print it out. Instead of showing all the, or letting it decide, we can say just give us the top 5 rows. Now we have cut down the columns from 39 to 21. And that's good so far. Let me see if there are questions. I don't know if you are hearing me or if you can hear me. If you can hear me, then let me know, because I don't want to be talking to myself and recording this when it is not, or when you cannot hear me. And so this is the data that we have now so far cleaned. Another thing I will do is the hospital names. I would like to just transform them to capitalize them, and I would like to convert all these columns to numeric. You see, there is not available here. So there are criteria that are used by CMS. So not all hospitals receive star rating. You have to have at least 3 measures out of 5 measures or domain, and then 2 of those, or 1 of those, I don't want to misspeak, I think 1 of those has to be either the safety domain or mortality. Yeah, I think something like that. So let me come down here. And again, we are going to say hospital. We are going to override it, but still keep it the same. So we say hospital. Then select. No, we are going to use with called. And then we say cs dot string. So all the string columns, we are going to pull them out, and then we are going to say dot to title case to capitalize them. Okay, so it's a string, so it's str dot to underscore title, and then let's inspect output, print hospital. Oops. Now we have capitalized the hospital names and it's looking good. They are looking good. Next thing to do is to convert these to integers, and by doing that we are going to make this one too. If it's not available, then we are going to make it NA. So we will come down here and we'll say, okay, hospital. We are going to say select CS dot let's say contains count, because we don't want to include the facility column in there. So let's say count, and then we say cas, and then pl dot integer 64. Let's see if this is gonna work. So that didn't work. Okay, so this is saying conversion from the string to I64 failed in column group underscore count. Okay, let me check that column. Okay, let's with columns. Okay, let me do this one. I will say hospital underscore overall rating equal pl.call. So we take that column and so this. Okay, let me check something real quick. Let me make sure I got the correct column name. Okay. Peter Gas. Okay. So this is what you need to do. Because here Paulus is telling us that conversion from a string to the integer 64 failed in column there. So what we need to do, we need to set restrict. We are going to set it to false. And then when we do that, it's going to tell Paulus not to worry about it and do the conversion. So now we have converted that. And that's why it didn't want to accept it. Okay, this is by default is set to true, but we want to set it to false. So what I want to do, let me copy this. What I will do, I'll come down here. I'll start over again, and instead of using with columns, I'm going to use select. And select, I will start with contains count. If it contains count, or if it is, or if column is, I'm going to remove that. If a column contains count, or it is the hospital overall rating, then we are going to cast that to integer 64. Now that does the trick at once instead of breaking it down. But then the hospital column, the hospital name column has been dropped because we use the select method. So this is where you want to use with columns. And now this is what we wanted to see. Now we have all these numbers. Everything has been converted to numerical or integers. And we are now going to work with this. As I mentioned earlier, that we will just look at the hospital overall rating, and we probably continue the rest of tutorial next time to pick it up from where we will stop. But now let's pull out. So we will pull out just a single column. So we will say, let's save this data. Okay, so we want to wrap it in here. Oh, it was outside hiding there. So let's come here and say hospital. Maybe this time we call it DataFrame. And then we will bring it here, hospital DataFrame. We will say that get column. And the column we want to get is the hospital overall rating. And then now let's say we want to look only at unique values in this column. And the unique values in this column, as expected, are 1, 2, it stars 1 through 5, and then the null. So those that are null, we are going to filter them out. Let me copy this. And here we will come to filtering data. So we'll filter data. We will say we will use the filter function. And the filter we want to call a column that we are interested in. Here we are interested in hospital star rating. We are going to say dot is, we want to see, we will use is not null, but let's look at the null values first. So we need to close this one. We don't need the unique function there. And let's print this one. So how many? There are 2,564 hospitals with no star ratings. We don't want those. We want to exclude those. So one way we can do this, we can say we can use the tilde and do this. And when we say it's not a star, so it's not doing it. So this is not the right way. So we are going to say, instead of saying it's null, we are going to say it's not null. Okay. And we are getting, oh, I know why. Let me run that. Okay, yeah. So we had written the data frame because we are calling it the same thing. So when you do that, that's not the best way to do it. So instead of doing that, we can say hospital stars, or we can just say stars. And then stars is what we are going to print out. But again, this is not just the stars. Oh, sorry. This is not just the stars because it is still has the other columns. We did not select this column alone. If we wanted, we could have just select it out and pull it out. But now what we have done, we have removed all the hospitals that do not have star ratings, and we have all the hospitals with star ratings. So that's one way you can filter. So here we are filtering with one column. Another thing we can do is, so we call hospital data frame. We can say dot drop nulls, and this is gonna drop all the nulls values. So this is giving us 2682. Here we are 28, so that has dropped more from another column. So that's not the best way to do it. Another thing we can do, we can filter by just looking at, so maybe let's say we say CS dot integer that is between maybe 3 and 5. Okay, so that did not work. This is ambiguous. Try to combine the predicate with all or any expression. Okay. So we are going to say all. Okay, so that's not the right way to do it. Let's use this column again. And here we can use the dot is between, and we are only selecting hospitals with star ratings between 3 and 5, that is 3 and above. We could have done it this way. We could have said greater than or equal 3, and that could have given us the same results. You can also use, so instead of doing that, you can say star rating is greater than or equal to 3, and then pick another column and say maybe what we are going to do is S dot contains count greater than maybe 5. I don't know if that's going to work, but that did not give us anything. What about greater than or equal to? Okay, that did not work as well. Let's see these columns here. Maybe let's take this column here. Okay, so we can filter here using this combination of conditions. Or another way we can do this is saying or. So what we could have done is we can wrap this in parentheses and say, instead of saying comma, we could have used the or and do this. Okay, something didn't come out right. Oh, it's not or, it's and. Oh, instead of using this and this, use this and this. Okay, I know why. Yeah, so when you are doing this, when you're going to use the conjunction here, like or and, make sure each condition is wrapped in its own parentheses. Like you say, tell Paulus that this is one condition, and then that's another condition. That's why it was throwing an error, and it gave me some hints on how to solve that or fix that issue. Okay, so the final thing I'm going to do, because this has already been 1 hour, is maybe let's look at this. We made a mistake. We wanted instead of the hospitals, or let's say maybe we need the hospital, we needed the estate. So next time I'm going to include the estate columns, but we will pick it up from here next time. Let us do one more thing. Let's look at hospitals by star rating. So we are going to say, so let's say stars. And then say that group by hospital overall rating. Let's see this one. What I will do here, I'll just select two columns. I'll select facility ID. Oh, no, facility name. Hospital overall rating. Then I'm going to do total equal count. Oh, so I should have not done that. I should have done this. That count. Okay, so and I'm going to sort it. let's sort total. We are going to do it in descending order. Okay, so the highest star ratings, so hospitals, there are 828 hospitals with 3-star ratings. There are 763 hospitals with 4-star ratings or 4 stars. And there are 590 hospitals with 2 stars. There are only 381 hospitals with 5 stars. And there are 271 hospitals with just a single star. This is gonna do it for now, but next time we will pick it up from here. We will go back, add the state column so that we can see these hospitals by state, and then we do summarization, group by and summarization by state and hospitals, and we see all this actually by state, and we see how each state is doing and how each state is doing in each of these categories, like measures. So briefly, this is how you import data into Jupyter Notebook using pl.read_csv or Polus package. Check for missing values, work with columns, select columns, transform column names, pull out a single column, filter data, and select columns using different ways, using select or selectors, Polus selectors. So this is a brief introduction into getting started with Polus package. And next time, maybe tomorrow, around the same time, we will continue from there. Thank you all for your time. Please share our videos, leave us comments on things you would like us to cover and how to improve on our tutorials. And don't forget to follow us on YouTube, Facebook, and LinkedIn. Take care. This is Null Quantum Insights, where we are bridging the gap between R and Python. Instead of focusing on the differences between R and Python, we help data scientists and analysts to leverage the capabilities of these two powerful data science tools. Thank you.